Welcome to this video about solid principles in .NET. In this video, we'll explain what solid principles are, why they're important, and how to apply them in your .NET applications. Solid principles are a set of 5 principles for object-oriented design that can help you write code that is easier to understand, maintain, and extend. The principles are acronymized as SOLID, with each letter representing a different principle. The 5 solid principles are: S. Single responsibility principle, O. Open-close principle, L. Liskov substitution principle, I. Interface segregation principle, D. Dependency inversion principle. Let's take a closer look at each principle and see how they can be applied in .NET applications. The single responsibility principle, SRP, states that a class should have only one reason to change. In other words, a class should have only one responsibility. For example, let's say we have a class that calculates the total price of an order. If we add the responsibility of generating a receipt to the same class, then the class will have 2 responsibilities. The open-closed principle, OP, states that a class should be open for extension but closed for modification. For example, let's say we have a class that calculates the price of a product. If we add a new product type, then we should be able to extend the class without modifying its existing code. This follows the OP. The Liskov substitution principle, LSP, states that subtypes should be substitutable for their base types. For example, let's say we have a base class called animal and 2 subtypes called dog and cat. If we write a method that accepts an animal object, then we should be able to pass in a dog or cat object without any issues. This follows the LSP. The interface segregation principle, ISP, states that clients should not be forced to depend on interfaces they do not use. For example, let's say we have an interface called isShape that has methods for calculating the area and perimeter of a shape. If we have a class called circle that only needs the area method, then we should create a separate interface called the area that only includes the area method. This follows the ISP. The dependency inversion principle, DIP, states that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions. For example, let's say we have a high-level module called order processor that depends on. That's it for today.